Hello everybody, welcome back. This is just going to be a quick part 2 for partial fractions for calc, in this case BC. I realized that I didn't put enough examples, so in this video we're just going to go over 2 more examples. We're not necessarily going to solve it, but we're going to decompose them. Okay, so if you weren't there for the previous video, you should go watch that. But basically, we're using the idea that you can combine two fractions by finding the greatest common factor, then adding them together. So we're reverse engineering that using variables a and b, and we use systems of equations to solve. That was the previous example. Okay, so this is today's example. The first thing that we should notice is that we can factor out the bottom. It will become, let me get my laser pointer, x cubed on this side, x squared on this side. So we can factor out an x squared. So it'll be x squared times x minus 4. So this is a lot more complicated than the last one, mostly because there's a lot more factors on the bottom. But what we did was, because x squared is basically x times x again, what we actually have to do, instead of just doing ax plus b, we actually have to do ax plus bx squared, because well, once you get into the next problem, you'll understand why we have to separate it by this certain amount for each one, because otherwise it won't combine correctly. And as I was trying to do in the previous video, when I was making that, I tried creating a complicated example like this. I forgot how to do that myself. Then I got the wrong answer, so I decided, okay, let's create a part 2 and where we actually do this correctly. So we now simplify, not simplify, but add them back all together. And so for this one, we're just multiplying by x times x minus 4. This one is just x minus 4, and this one is just x squared. Combine them all together. I'm not going to group them together like I did last time. I'm just going to go straight to the system of equations. Oh wait, psych. I actually did. A plus c times x squared plus b minus 4a times x minus 4b. All over x squared times x minus 4 dx. dx is important. Don't let Symbolab tell you, oh, you don't need the dx when you're writing on our calculator. You're going to need that dx. It's very important. For the AP exam, you forget to write this on a free response, you're done. They start removing points. So let's get back to the original equation, where it's in this case 0 times x squared. So a plus c is 0. b minus 4a equals 4. And negative 4b equals 9. Well, this is not really a 3 systems, 3 equations, 3 unknowns. This is more like 2 equations, 2 unknowns, because b can be solved for directly. Negative 4b equals 9. I don't even need to go to the answer key to look and see that b has to equal negative 9 over 4. And once you get to that, it's self-explanatory. Negative 9 fourths minus 4 equals 4. You can solve for that on your own. And then c is going to be negative a, so you just change the sign from positive to negative, or negative to positive. So b equals negative 9 over 4, like I said before. You notice that a is c times negative 1, and same thing the other way around, is negative 25 over 16, c is 25 over 16. Now we can just put these in for a, b, and c. So this one, if you were to take the integral of it, it's the natural log of a times the natural log of x, plus, well, minus, because this is 1 over x squared, or b over x squared, so this will be minus b over x, plus c, natural log of x minus 4. Note, when I say natural log, I have to make a correction. I actually mean absolute value. A natural log of the absolute value of this denominator section. Because it doesn't exist. The natural log of something doesn't exist when x is negative. So it's essential to remember. Put your argument, this section, inside absolute values. And here's our answer. Well, what we could do is we could just divide this by x using properties of logarithms like we did in the initial video. But then you would have, I don't want to do that for this video. If you were to do something where they were just like, oh, just take this and use it to solve an integral like from 0 to 4 or something like that, well, you wouldn't necessarily have to use that. If you were doing this on a calculator, this wouldn't even show up for you. If you have to show all your work and just get it to an end result, then you would probably just stop at this, plug into your calculator, solve. But if it does say simplify it all the way, like my math teacher told us to do for some other problems, you're going to have to use your properties of logarithms, get this to 25 over 16 natural log of 1 minus 4 over x, all in absolute value, plus 9 over 4 times x plus c, because c's are essential for indefinite integrals. You don't need this if you're doing definite integrals, only for indefinite. Just a quick review thing. Okay, this one, I intentionally made it so we only have to decompose it because I noticed that there's a lot of factors that you have to go through. 1, 2, x squared plus 1, and then 2x squared plus 3 all to the power of 3. And why did I do this? Well, it's going to explain what we have to do for the previous one. We have an x plus 1 situation. X plus 1 divided by this whole thing, dx, because it's the integral. So, instead of actually solving this, we're going to decompose it. This is, if you were to start trying to solve this problem, this is what you're supposed to get. A over x, because x then x squared, plus b over x squared, plus, because the x squared plus 1, cx plus d, because all the lower powers of x squared are x, and x is a 0, which is 1, so cx plus d over x squared plus 1. Now time to go through the powers of 2x squared plus 3. Now, if I were to write this out, distributing it like I did with the x squared, this would cause total mayhem, so we're not going to be doing that. I'm just going to leave it like how it is right now, and we'll, well, if you were to solve this problem, good luck. It's a lot of variables. Hopefully, most of them are self-explanatory once you start solving it. X plus 1, x plus 1. Well, solve this one on your own if you want. This is the end of this video. It's a very short video, just going on about these two small examples, which help explain a little bit more how you're supposed to solve partial fractions for calculus. And I'll see you guys next time. Like and subscribe. And if you want to see part 1, just go to my channel. It's still there. It's the video I made right before this one. So, there you go. See ya.